Hello everyone, welcome back to talking about the surface area. Today we're going to focus on cylinders. Now before we get started, take a moment to pause the video and talk about for the warm-up, what is the difference in your own words between lateral area and total surface area? Well, to kind of recap what we talked about in the first lesson with our prisms, the biggest difference between the lateral area and the surface area. The lateral area is the area of the faces around the figure, right? Our sides around the figure. Right. What they do not include, the bases of our figure. On the other hand, the total surface area is the surface area of the entire figure. Everything you can touch on all sides, including those bases, not included before. Okay? Now today we're going to shift our focus from the lateral area and surface area of prisms to the lateral area and surface area of cylinders. Now a cylinder and a prism work extremely similar, except for in our cylinders, our bases are not going to be polygon, they're always going to be circles, right? So we're going to have surface area that will include those circular bases and lateral area that will just include around our figure. Now, I like to always think of lateral area of a cylinder like a soup can, right? We have our soup can, and if we peeled off the label of that soup can and unrolled it, it would have that rectangular shape around it. That's our lateral area. The total surface area would then be including our bases in on that as well. So lateral area label, and then the top and the bottom of our soup can included is the total surface area. So notice the formula for lateral area of a cylinder is 2 pi r h. So that talks about that 2 pi r piece of it. Think about how the perimeter of a circle is the circumference. So it's still perimeter times height, it's just 2 pi r is the circumference, the perimeter of a circle. And then in order to get the area of the base, well, the base is also a circle, so that's pi r squared, so 2 times the area of the base. So it goes back to what we talked about with the prism stuff, right? But we just know the area of the base is always going to be pi r squared because all circles are pi r squared. Before, we had to figure out what shape our base was before we could officially find what the area was. So for all of these examples here, we're going to find not only the total surface area, but also the lateral area of each of these problems. And notice in order to do that, again, we need to identify from the beginning basically two things. We need the radius of our circular base, and we need the overall height of the cylinder, which again is going to be the distance between your bases. So if we look at the first example here, our radius is 6, and then the overall height of this figure from base to base is this 8.9. So our height here is 8.9. So when we're looking for the lateral area, we have 2 pi r h. So if we plug that in, we have 2 pi r, and then 8.9 is the height. Now, if they are asking you just to round this answer, you are going to type everything in as is. So 2 times pi times your radius value, which we said was 6, times that height, which is 8.9, for a total lateral area of 335.5. Right, and it's area, so meters squared. Now total surface area then is going to take that lateral area that we just found, so it's the 335.5, and we're going to add on to it 2 times pi times your radius squared. So again, we're going to take that value, 335.5 plus 2 pi times our radius squared, for a total of 561.7-ish meters squared. Now for the next problem, try this one on your own, right? See what you get. Again, identify first what your radius is and also identify what the overall height is. Plug into your two formulas for lateral area and total surface area. Now double check your answers, but for the lateral area, you should have gotten a value of 219.9 centimeters squared, and that's going to come from multiplying 2 times pi times your radius, which is 5, times your height, which is 7. And your total surface area then is going to come from taking your lateral area plus 2 times pi times your radius squared. So you should have gotten a total of, when you calculate this, just over 377. So just beyond that, centimeters squared. Okay. Now, be careful in examples like 3 and 4, because again, we start these problems by looking for the radius and the height. Well, the problem here is they're not giving you the radius, they are giving you the diameter, right? They give you the whole span of that circle. So the first thing you need to do is calculate the radius by dividing your diameter in half, and then you're going to find the height by multiplying, by looking for those distance between the bases, which is 11.1. And again, and for lateral area, 2 pi r h is the formula. So 2 times pi times your radius times the height, which, if you calculate this using that pi button, 2 times pi times that radius times the height. We have a lateral area about 488.2. And then we're going to add on to that value for the total surface area, 2 times pi times that radius value of 7 squared, for total surface area of 796.1. So again, lateral area is 488.2 meters squared, and then the total surface area is that lateral area plus 2 pi r squared, for a total of 796.1. Again, take a moment on your own. In number 4, again, be careful of what they are giving you. Pause the video, identify the diameter and then the radius, as well as what is your height of the figure, and then calculate that total lateral area and total surface area. All right, check your work. Lateral area, you should have gotten that the radius is 7 again. Okay, this time our height was 15 after we divided that diameter 14 by 2. Our lateral area is 659.7 meters squared, and then total surface area to take that lateral area plus 2 times pi r squared, you should have had 967.6 meters squared. Okay. Now, moving on to the back side of the sheet here. All right, we have a couple word problems. So notice this first piece here is asking us to find the height of the cylinder that has a total surface area of 703.2 and a radius of 10. So notice a couple things that they are giving us here. They're giving us the total surface area is 703.2. They're giving us the radius. What we need to do is take that surface area formula and we need to find for ourselves what that height would be. Now notice the way I wrote the surface area formula right now, there isn't a height included, right? That lateral area plus 2 pi r squared, there isn't any height in there, right? We don't see h. So this is where you're going to want to rewrite that surface area formula. Instead of saying LA, you're going to use the formula for LA, 2 pi r h plus 2 pi r squared. Okay, so now we see that variable h in there that we're going to eventually be solving for. And we're also going to plug in what we were given. So we were given the surface area to start with this. So we're going to plug in that 703.2. Right? And then we had plugged in already 2 pi. Well, the next thing that we were given in here was that radius value of 10. So we're going to plug, we're looking for the height. So but we're given that radius, so we're looking for that 10. And then again, the height is what we are looking for here, so we're going to leave that h. And then again, plus 2 pi. The r then is again 10 squared. Okay, so with everything plugged in that we have to our knowledge. So what we're going to have to do is we have to be careful. We need to simplify everything first to get h by itself. So on the left-hand side here, the 703.2, that's okay. That's already simplified. The next thing we need to do is we need to take 2 times pi times 10, and we need to simplify that so that we get about 62.8 h. Okay, so we simplified 2 times pi times 10, and then same thing over here, 2 times pi times 10 squared. Get a total value there of about 628.3. All right, well, again, your goal is to get h by itself. So we need to subtract from both sides the 628.3. So 703.2 minus the 628.3, and we get 74.9 equals 62.8 times the height. Last but not least, we're going to have to divide to get that 62.8 away from the 62.8 away from h. So we're going to take that 74.9, divide by the 62.8 for a total height value of 1.2-ish if we're rounding to the nearest 10. So your height is 1.2, and a reminder, that's just going to be meters because it's not an area. So 1.2 meters is your final answer. Okay. Now, last example here goes back to talking about our cans. So we have some spaghetti in a jar, sauce that we're trying to make, and the can is 5 inches tall with a diameter of 2.6. So height of this is 5, diameter 2.6, and we want to design the label for this can. We want to decide how many inches of paper, square inches, will it take to cover the can. Again, you are not covering the bases of the can. So that goes back to our example here. The label around our can is just going to be in reference to our lateral area. So really all we're looking for here is lateral area, which is 2 pi r h. So again, before we get started, very similar to the examples on the bottom of the first page, they give you the diameter, you need the radius. So we're going to start by cutting that 2.6 in half. We're going to get 1.3, and then plug in 2 times pi times r times h, and if we plug this in here, 2 times pi times r, and then h, get a total of about 40.8 square inches is how much paper we are going to need. Right. And there we are for our lateral area. So again, it goes back to thinking about, do I need total surface area? Do I just need lateral area? Or do I need a combination of the lateral area and maybe just one base? Last but not least, a little closure activity. Think about, for prisms, for cylinders, you could choose either example. Maybe you have more than one, but what is a way that people would use lateral area in the real world? Take a moment to answer that. Well, you could have chosen maybe the soup can example that we just talked about above, but going back to prisms yesterday, think about when you paint a room, right? Let's say you want only to paint the walls one color, but your ceiling a different color. If you want to paint the walls, but not the ceiling or the floor, that's lateral area. Okay. Well, thanks, guys, for another great lesson, and good luck with your practice. Have a good day.